right, we talked about elongation. Now it's time to talk about how to stop transcription. So how do we stop transcription? It's actually super duper easy if you're a prokaryote. All that happens is you hit a Terminator sequence. The Terminator. So your RNA polymerase 2 moves along the DNA and then it hits the Terminator and the Terminator knocks it off. And the RNA polymerase 2 separates from the DNA, and then the transcript separates from the polymerase, and then you are done, right? So the Terminator sequence is A, in the DNA. It's in the DNA template. And once you hit the Terminator, RNA polymerase 2 is disconnected from the DNA. The RNA transcript, it disconnects from polymerase 2. And in prokaryotes, right, my transcript is mRNA and transcription is done. Right? So, in prokaryotes, things are pretty easy. So, it's a little bit more difficult if you're a eukaryote. So, if you are a eukaryote, things are a bit different. There's no Terminator sequence in the template strand that causes transcription to stop in eukaryotes. So how do you stop in eukaryotes? Well, a certain sequence is produced in the mRNA, right? So you need a sequence in the mRNA to stop the whole thing. I said mRNA, RNA transcript. This is important vocab, gotta be pedantic here. You need a sequence in the RNA transcript to stop. And what is that sequence? Well, it's not the Terminator, unfortunately. No Arnold impression there. Terminator was a great opportunity to bust that out. Now, here we have the polyadenylation sequence or signal. What is the polyadenylation signal? Right? It is in the RNA transcript, and it is A, U, A. Polyadenosine. Oh, but you know what? I could maybe bust out some Arnold Schwarzenegger on here. So you continue your transcription
all the way through, but then something terrible happens. It's going to stop it, and it's going to go. And that is what's going to cause transcription to end in the eukaryotes.
Basically, once your polyadenylation signal is produced, so we have our AUG, we had AUG, then we had CAU, then we had AAA, then we had AUA, AUA, and then we had AAA, or AAU, AAA, and that's going to be our polyadenylation signal. And basically what's going to happen is that we're going to have some enzymes cut the transcript off the signal, right? And then we're going to knock polymerase 2 off our chromosome, and then they're going to cut the signal off poly 2. And that's how we stop there. And so we'll just, come here, give me the thingy. Cut this right there. And we'll have polymerase 2 with its signal knock off there, and then we'll just cut that off. And this is just going to get recycled, which isn't important to know. It's not even important to know that the enzyme is cutting the signal off of polymerase 2. The important thing to know is that our enzymes cut the transcript off from the signal, so the signal is not part of our transcript, and that they knock polymerase 2 off the chromosome in order to stop transcription. So, there we go. And what do we have? In prokaryotes, once we stopped transcription, we had mRNA. In eukaryotes, what we have is an RNA transcript. And it is not mRNA. Next step that we have to go through is RNA processing. And this is eukaryotes. And this is the subject of our next Biology Bite on transcription.